We're going to be looking at another data set that I find really interesting and the different packages that we use. I'm not diving into all of them individually because this is like a continuation of the first book I wrote where you were introduced to some of these in more detail. But I do want to guide you. We're going to be using pandas for the data frame and Folium for that Pythonic leaflet integration and Skylearn where we do the machine learning and predictive analysis, NumPy, which arrays and these big data sets and relationships, and Plotlib for plotting. And I will be sharing the code and maybe providing some background information. But my point is to show you the integration of climate science and Python in this short course that I put together. So let's explore mapping human activity at sea from space, because the satellite imagery can show a lot of this industrial activity. We tend to focus a lot on transportation and activity on land, without really playing to do justice to what's happening over our oceans. And this is me clicking into the website that you saw, the Global Fishing Watch. And I'm just showing you that they're showing how the footprint of human activity at sea is revealing these unmapped industrial uses. And these all contribute to the health of our oceans, the whole ecosystem, the biodiversity, all of that, the pollution. And sometimes we need more data to be able to bring a more 360 perspective. And there's a lot of data here. And I'm showing you over here, this is just a snapshot of what's listed on this page. Vessel detection. You can look at infrastructure, which would show you some of these wind turbines and the oil rigs and all of this information that is so relevant in geospatial when we're able to use location. Now, this was when I was in QGIS first, because I go there really quickly just to take a look around. And then if I see things that are interesting that I want to share with you in Python, I do that there. And when you're in QGIS is a good opportunity to be able to scale down that data. These are huge files. And I have the latest Mac and pretty high powered access in my home office. And still, this was huge. But I use this to bring the shape file in so that I can clip it. So I clip the data just to the regions that I want, so I don't have the whole world of all the vessels, because that's what you're going to return. You're going to return the whole world of vessels unless you filter somewhere. And that's why Python's really good. And I'll show you how I use that to bring the data in. So this is just a little how I clip that algorithm in QGIS, and then I was able to export it and save it in a format. And I could pull that into Python. I could pull it back into QGIS and have a much more manageable file. I just like to show you a little bit of different workflows because I'm a heavy QGIS user. Now, when we start looking at pulling this data in, let me just pause here and show you a little bit about what's going on. What I like about Colab Pro is I can pull my files in. They're usually only session files, but if you mount your drive, your Google Drive, where the data lives, it'll be more evergreen. You won't have to reload it every time. So what you're looking at here on the right is my data is here. And it's just, this isn't the view where you're going to see it. I'm just showing you here that when you run the code, it will be saved as an HTML that you'll open and you'll have access to the visual. Here, in this, where this little orange folder is, that's where I uploaded the CSV file. It's a very large CSV file. That's why I linked it with my drive. If I click this, I can pull it right out of Google and not have to worry about uploading it into Colab. And you'll also notice here, 10% was too much. I didn't have all day to wait for this thing to load. So I just did 1% of the available data. And random state just shows you that number, which is funny because it's the number from Hitchhiker's Guide to the Galaxy, the answer to the universe. It's 42. But if you pick the same number in your random state, whenever you run this, you'll get the same data. Otherwise, if you don't do that, it'll be so different every time you run it, if that makes sense. So we have our year category. This is how I wanted to look at the data. Wait, let me go back. I wasn't done. You can look at the data any way you want by age. You have to know what your variables are doing. And I'll post that as another little image, but you just run your variables to know that you have a category called match category, year. You have to know what your variables are to be able to call them into the code, obviously. And what I decided to do here was to do the fractional, so I only pulled in 1% of the data, and now I wanna look at it from the particular year of the data, and then I also decided I wanted to look at certain types of ships, of vessels. So, I guess this probably should have come before that, but you can see what the variables are. You have matched categories. There's fishing, non-fishing. So you want to try to think of, I'm at the Panama Canal here, and I don't think a lot of people hang out there to fish. It's usually things are moving through. So there's different types of vessels. You can look at the size of some of these vessels if you want to do a linear transportation infrastructure calculation. There's a lot of information here. You can look at the different years that are available. There's just a lot of information here. You have to know your variables to be able to decide what questions you can ask. And this is just a sample. This is that HTML that was generated that's showing me that tiny little sample, the different clusters that were generated using sklearn. And you can see them here. These are 2 different years, but you can see the vessels here, and you can think about the different types of information you might want to get. These are just little snapshots so that you understand. You can look, how do these vessels move through? You can look how they're influenced by geopolitics. What's the marine biodiversity? Are there any environmental changes or ecosystems that limit where they can go? You can look at the different climates, the fishing pressure. This is all data that you can find and layer on, and environmental compliance, seasonal variability. If I decide I want to look at the data in the spring versus the summer versus the fall, and then you can also learn how to integrate your data. These are big ideas of where we can go with the vessel stories. And that's just an introduction to what we're doing in this section.